The sun plays a much larger role in Earth's long-term stability than daily weather patterns would suggest. Solar energy drives climate systems, but solar activity also influences Earth's magnetic field and atmospheric chemistry. In recent years, researchers have explored how large solar events like coronal mass ejections and solar micronovae might act as trigger for wider changes. Solar forcing can lead to disruptions in the geomagnetic field, which helps shield the planet from cosmic radiation. When that field weakens, radiation levels at the surface rise, impacting both DNA integrity and atmospheric dynamics. These shifts ripple through ecosystems and may contribute to widespread environmental change. Patterns in solar cycles appear to overlap with known extinction windows. Several peer-reviewed studies have suggested links between solar behavior and biodiversity loss, especially when paired with geomagnetic fluctuations. One example is the Lachamps excursion. A 2021 study in Science by Cooper found that this magnetic weakening likely influenced solar conditions, correlating with two major ecological and cultural changes. They wrote, the temporary breakdown of Earth's magnetic shield during the Lachamps event could explain many major transformations. These include megafaunal extinction, cave art booms, and migrations. While correlation, of course, does not guarantee causation, the timing supports the idea that solar shifts play a major role in terrestrial change. These cycles are regular enough to study and irregular enough to surprise us. Sediment records and ice cores help ground these theories in physical data. Layers of beryllium-10 and carbon-14 produced by cosmic rays spike during periods of weakened magnetic shielding. These markers show up in polar ice samples and deep-sea cores aligning with known solar minima and geomagnetic excursions. In several cases, these spikes coincide with signs of cooling, fire, or flood events in the geological record. When these magnetic fields weakens and solar activity is high, more cosmic radiation reaches the Earth's surface. This affects climate patterns, mutagenesis rates, and possibly tectonic activity depending on the scale. The patterns suggest a feedback loop between solar cycles, magnetic shielding, and Earth's environmental responses. Together, they point toward cyclical disruptions that align with the larger pole shift framework. If solar activity can disturb Earth's protective systems, then it can also act as a timer for crustal instability. This connects the dots between solar physics and geophysical movement, setting the stage for models that include both external forcing and internal tipping points. The micronova theory, though still under review, offers one way to explain bursts of solar energy that exceed the usual cycle. Events of this kind would raise global temperatures, weaken the magnetosphere, and redistribute atmospheric mass. All things that could trigger displacement in a sensitive system. From fossil layers to magnetic anomalies, the evidence forms a repeating structure, and that structure includes mythic memory, fossil shifts, and climate collapses tied to solar timelines.